Looks like it's gonna be another allergy day out here, unfortunately. How's everyone doing this fine evening? Well, morning for us, but just getting started here. Got my coffee in me. Now hopefully I have a little bit more energy than I did when I was waking up. You got some people here already? How y'all doing? Alrighty. Just chilling out for a second. How's it going? Alright, well, before we start getting too in it, I'm going to go ahead and paste our Discord for anybody who's dropping by. Actually, maybe we'll see if there's more people drop in for a second, and I'll drop it. If you haven't checked it out already, there is a GitHub for this project. I'm going to paste it in the chat. Just if you want to follow along, build on your end, test things out, you can go ahead and do that. I'm actually, something's bothering me here, so I'm going to fix this. While we're waiting, where's our README? Zig fighting game, okay. I'm just going to commit that because it is bothering me. Alrighty. I have some changes to main. I don't see any. Weird. Okay. Alrighty, we have some people in here, so I'm just gonna go ahead and share the official Discord for this project in the chat, just so you have it. If anybody wants to come by and just talk about this project in particular, or whoops, this is the wrong title. This should be a different title. Hold on, give me a second. Okay, just updated that title for the stream just in case, just so there's no confusion. Let's see here. Alrighty. Mover properties, that's not the right. I definitely probably should get a second cup of coffee. Definitely improbably. Alrighty. Okay. I absolutely cannot type today. Okay. There we go. Okay. Well, just going to go over the planning notes for today. Or just reviewing last time. Well, last time we got our basic state machine working. I probably should plug in a controller here. Just to show it working here. We're able to move around left and right, or just left, I guess right at the moment. I don't have a walking back yet, as you see on the controller. So, okay, that works. And you can see down in the debug, we have going from walking forward to standing and back. And we have the callbacks working. If you were here last time, I know some of you missed it because I didn't actually post a link on Twitter. But yeah, we have our common states for everything. Our standing, our walking forward, crouching. Well, crouching is not really implemented yet, but yeah. Okay, so this time I want to demonstrate, well, hitboxes, collisions, things like that. But for now, let me update the title, make more sense. Yeah. So we should update the planning doc a little bit more. Oops, that is the get diff file, not that. I want to do hitbox collision. Okay. Okay. Cool. So this is starting to get a more interesting part. Basically, the idea today is we're going to implement storage for hitboxes, implement some basic collision, and we're going to display it on screen using some kind of debug display. But in order to do that, we're going to have to convert our in-game coordinates to screen space coordinates so that it's actually displayed correctly. We don't have something like that. So for now, let's go ahead and do that. Let's do this as a first thing. It's kind of the boring part, but it's going to be required. So I'm going to go ahead and just drop that in my math library. So let's just go, let's not be a constant, it's going to be a function, world to screen. And we're going to pass an integer. Everything in our game is going to be integer for now. Or maybe we'll return float. I don't know. Let's just start with integer. Okay. And let's just give, we're going to have to make, we should make a, let's just make a vector version of this. That's the easiest thing to do, I think. Yeah. Okay. And vector 2D. We'll probably make two versions of this. You know what? Let's just start with the basic version, just in case. Okay. It's int 32D, and we need to return an int 32. What's not int 32? In Zig, it's I32, right? Okay. And we can return. For now, we're just going to assume that our screen space is about 1/1000th of our game space. So let's just do that. So we're going to do return coordinate divided by 1000. Or we can just do this. Divided by 10 divided by 100 by 1000. Okay. Let's just make this more obvious. So I'll just do division for now. And now we can do something like this. Let's go to our main. Let's go ahead and make a, yeah, let's do this for now. And you see where we draw our position on screen? We're not going to draw position directly like this, right? We're going to do like const screen x equals world to screen. Oh, it's going to be the math world to screen, right? And we're going to go, let's get our position here, our two positions. probably see now why I want to make a vector one, right? And then instead of doing this, now our screen space is going to be 1/1000th of whatever our world space is. So when we run the game, the character's not going to move very much. So we're going to increase their speed. Oops, that's something that doesn't work. Give me a second here. Division with sign enter must use. Oh, we have to be very explicit about that. Okay. Oh, yeah, there's not automatic conversion in Zig. That's one of the nice things, right? Div Trinicate. Okay. Let's just, you know what? How does that work? Let's look at the documentation. Div Trinicate. Div exact. Exact division color guarantees denominator does not equal 0. And okay, we just use it like that. Okay, so we'll use div exact. Div exact. Because we can guarantee our denominator is not 0. Oh, we have to include. Oh, it must use div trinicate. Oh, never mind. It's still just complaining about that previous error. Okay. Oh, we got a breakpoint. What do we do? What did we mess up? Does not like this. Okay. Can we do this? Trying to learn a little bit about Zig here. Okay, we'll have to manually convert, right? Let's try division by trinication. Okay, that works. You see our coordinates way up here in the corner. That's where they're starting. So what we're going to have to do is go back to our main, our initialization code. Where do we initialize that at? Was it in main? I think we did. Okay. Yeah, we started at 4,000. So it's actually going to be 1,000, right, of what we wanted. So we're going to start at 200,000, 400,000, 200,000. Should be right. Oops. This is 1,000 pixels, 10, 100,000. 1,000 pixels, 10, 100,000. Okay, so that should give us the right position at least, because we've now increased the range of coordinates that are visible on screen. So it should be about center there. Okay, but we need to update the physics of our velocity. And let's see, where's walking forward? Right now, the velocity changes to 2. We want to change it to 1,000, 2,000. So that should give us the right speed. Okay, there we go. Nice. Okay, I'm just going to go ahead and just add that simple change to get real quick. Okay. There we go. Go ahead and just push that just in case. Okay, nice. So we've done that. Where's our planning notes? Okay, we did that part. Okay, so this is kind of vague. So we need a data store if we're going to do hitboxes. The reason I did the world coordinate stuff first is because I want to implement hitboxes using the same coordinates consistently, so I don't have to update it later. So we're going to need some kind of like persistent data store for our character properties, like all the animation used, things like hitboxes, of course. We need some kind of like events that would trigger like sounds and stuff like that. But for now, we're just going to focus on hitboxes and maybe like the length of an action before it ends. So we're going to have to support that. So let me, I don't know if I'll go technical design here. Let's just start things here. This is not very super organized, but go ahead and just do this. Okay. I'm just going to say character data. Data. And then what do we need to store? Obviously hitboxes. Oops. Frame length of or duration of an action, so that an action can play through, and when it's finished, we can go to the next action. Hit properties. Let's say maybe, eventually we're gonna have sound effects, animation, and then we're gonna have transitions eventually. I'll get to that at some point, but not today. Okay. Oh, maybe looping, not looping. And I think we might want to do looping sections. I'll get on that at some point. Looping sections / animation sections. Okay. That's going to basically, like, we can loop parts of our action through game data or jump into other sections in the animation depending on conditions that we set up. Okay. So that's a basic idea of what we're going to store in an action, right? And then in our character data in general, we're going to want something like, what about go to frame? That's going to be included in like the animation section stuff. Yeah. Okay, let's see. Like walk speed, jump speed, things like that. Max health. Like jump. Yeah, jump. Velocity. If we maybe, well, let's just say floatiness or just gravity or whatever name. To say things like that. Okay. This is kind of the persistent data kind of stuff I'm imagining putting in the game. There'll be other like properties, maybe health modifiers, things like that, or damage modifiers. I don't know. Let's just avoid that for now. Okay, so we're gonna have to create. Let's just go ahead and make a struct for this stuff, right? So we need the action properties and character data, and we're gonna have to store it somewhere. Okay. Okay. Right now, what is our folder structure? We'll just make it flat. We'll put everything in stores for now. All right, let's do a new file. Let's call it character properties. Character property. Or how do you want to store this as? Character data. I don't know. Let's just call it character data for now. And then within character data, we're going to have character properties. It's going to be a struct. And for now, the only thing we're going to put into it just for testing purposes is maximum health. So max health is a integer. Yeah. Okay. And then, I'm gonna rename this for, well, this is fine for now. Okay. And then we're gonna have our action properties. So action properties. This is gonna apply per state, or maybe it will be, we'll leave it per state for now. See, action properties. It's also a struct. And do I have to make it public to export it? I think. I always forget. Okay. And for now, we're going to put in a duration for it. Yeah. And we're going to have hitboxes as well. So the way we're going to structure hitboxes is basically going to be groups of boxes on a timeline. So think of something like this. So let's say const hitbox. This is called a hitbox group. And then hitbox group is going to have a start frame. It's supposed to be I32. And we're going to have duration of the group. That's also going to be a non-negative value. And we might optimize the runtime data for this stuff, but this is how we're going to store it while running. Well, definitely offline and when we're loading. And then we're actually going to need hitboxes, right? So we need a hitbox. It's going to be like this. So something like this. Do I actually need to make this stuff pub? I always forget. Oh, we'll do it for now. Okay. And hitboxes, how are we going to store hitboxes? There's like two ways we could do it. We could store like the top, upper left and bottom right coordinates, or we can do upper left and width and height. I'm just going to go with the width and height method for this for now. So we're going to do upper left. So let's see. We're going to have a X, which is the upper left. Let's just say top, so it's more clear what it is. Left. We might add like accessor functions in the future, and actually might be the best way to do this. Well, for now I'm gonna do this, and then we're gonna have width and height. Okay. Depending on how we're processing this, like this is gonna be great for editing, but not necessarily good for processing. And but we'll get there. Okay. So we have this data, and yeah, we're gonna have to have an array of hitboxes. Now, within our game, it's not gonna be a dynamic array, but when we're editing, it's gonna have to be some kind of. If we have an editor for handling hitbox drawing or whatever, we're going to have to make it some kind of resizable array. I actually haven't looked into this in Zig yet. So this is going to be the first time we're looking into dynamic arrays. So yeah, we're obviously going to have hitboxes here. It's going to be some kind of, it's not going to be an array, but it's going to be, the idea is going to be like, it's going to be hitbox, right? So that's not going to be that. That's the basic idea. So how are we going to have to do this? Let's do arrays. Oh, maybe they call it vectors. A vector is a group of Boolean integers which are operating on parallel. Oh, that's a different thing. Okay. Fancy array. Oh, I think it's called slices in Zig. Should not be there. That should be closed. Oh my. Seriously, I hate Windows. Just let me close it. Okay. Alrighty. Why don't more games? Some games use spheres. Some some games use spheres and pillars with angles. I use hitboxes, or what they're really referred to as like axis aligned bounding boxes, because they're really easy to process. They're really cheap. Okay, you just check to see if two boxes, if the like if like the right side of this box and the left side of this box are overlapping. Like if the left side of this box is less than the right side of this other box, that means, well, if they're, it's more, put it this way, if they're not, if that's not the case, then they cannot be possibly overlapping. So you can early out on those checks. Anyway, so I think what we're looking for is a slice for storing hitboxes. So a slice looks like this. Known at run times 0. What is that? Oh, it's just the size. To array.length. So they take the length of this. Huh. Slices do have array bound checking if you try to access something out. Oh, great. Okay. So I'm trying to learn how to use a slice. This seems to be their equivalent of like a vector from C++. So here they're like, they point a slice directly to the array. Do we have the alloc? No, we shouldn't have the alloc. What are the dynamic, what resizable array? I don't know. What can we use for storing our hitboxes here? Is there anything like that, actually? Are we going to have to manually like malloc a chunk of memory and just treat it like an array? Or is there actually some kind of standard library thing that we can use? No. I'll go to Reddit. Reddit is not really helping me. Oh, consider allowing variable length arrays. So it looks like we're gonna have to do like heap allocation. This is a multi-dimensional array of the type float 64. So runtime looks like this. You just multiply, okay? So we have to allocate something like this. Let's go to Compiler Explorer real quick. And try some of this code, because I'm not sure actually how to use do this dynamic array stuff yet. So let's just do what he's suggesting here. Or is this like So what I'm guessing what we can do is something like this. Does that compile first of all? It doesn't look like I don't have N and M. Yeah. Let's just say array of size 20 or something. Does that work? Compile failed. What's the issue? Unused local constant. Ew. Okay, that makes sense. Hold on. Let's see. Let's call it array. And to say array pointer. Let's say element number 5 should equal 10. I don't want to say, okay. What is the issue? Error dependency on libc must be explicitly specified in the build command. Oh. Okay. So I'm trying to think what pattern we want to use for storing. I don't know if it's a pattern, but I'm trying to think of the strategy you want to use for storing something like hitboxes, which can be resized. Doesn't Zig have array list? Let me check that out. What is that? Continuous growable list of items in memory. This is a wrapper around. Okay. Struct internally uses standard memory allocator for memory management. So this is part of array list. Okay. So that's just available to us. Hold on, I just want to see real quick. Oops. Okay, whoop. Let's call it standard array list. A contiguous growable list of items in memory. Yep, thank you, Avoid, for pointing that out. That's basically what I'm looking for. Okay. So I want to test that real quick. Actually, the easiest way for to do is just do it within the game itself. Let's go to our character data real quick. Actually, before we do that, what is the format for testing again? We do something like test name a test and try whatever. Okay. Here we go with our tests again. Let's see. All right. We're just testing this real quick. Oops. Oops, oops, oops. Let's go back here. Import our standard lib. Go at the top. Come down here. Delete this stuff. We can do a var recite array is going to be equal to standard dot array list. How's that going to work? So we have tests down here. Okay. So we need to do something like this. It's going to call a list. Okay. Testing allocator. Oh, we need a testing allocator. What is that? This is manually allocating, I guess. Oh, this is a testing. It's like a standard allocator for tests. Okay. I see. Yeah. So we have to defer deinitialize. Okay. So this defer command makes sure when things go to scope, it gets cleared for memory. Okay. So, like if we just test, oops, zig test source. Does that work? Undeclared identifier array list. Oh, it needs to be standard. Okay. All right, that pass. Let's do some other tests real quick to make sure we understand how it works. Okay. It's an array list unmanaged. That's interesting. What does that do exactly? I'm going to try something real quick. So this structure internally stores a allocator for memory management. To manually specify an allocator with each method call. Let's see, array list unmanaged. Okay. What is unmanaged? An array list, but the allocator is passed as a parameter to the irrelevant functions rather than stored in the struct itself. Oh, okay. Got it. So we can either like pass the allocator at the beginning or at the end, or for each function call to it. That makes sense. So what do we have? List dot. What can it do? We can add one, add as many as array, add one. Oops. Increase length by one. By the way, just pointing out how nicely this Zig language server is working. What add functions do we have? Add many as array, add many as array assume capacity, add one assume capacity. There's a lot of stuff here. Versus array adding new in elements which have undefined values. Return value is an array pointing to the newly allocated elements. Okay. The return pointer must become invalid when the list is resized. The return pointer becomes invalid when the list is resized. Does that make any sense? Resize list if, okay. Resize array. Okay. Got it. Kind of, maybe. I don't know. So we can see here the array list unmanaged. No, it's not very much different anyway. Oh, so we got the niche capacity like this. This is what I was looking for. Okay. What I want to do. Oh, I just want to be explicit here. So for people who don't really know, like Zig, I think forces you for any kind of dynamic memory management to decide what your allocator is. You can't just assume the system one, right? This is obviously great for games, right? Almost every game engine has their own set of allocators. Okay, let's see. So this initial capacity, is that going to work? Okay, I'm going to... Okay, standard testing allocator. Does that work? Yeah. Okay. So we can initialize our capacity to whatever we want. I'm gonna add another test. So can we do like list 5 equals 10 or something, and then try standard testing expect list 5 to equal 10. Does that pass? So that's not how you access. You can't use this syntax to access it. How do you access it? Is there a get, resize, slice? Hold on. If alignment, there must be a test here for getting it right. Oh, it's list.items. Okay. Got it. So maybe list.items. Contents of the list. Pointers to elements in the list. Slice are invalid after resizing operations. Got it. So let's say 5 equals 10. Should this work? Oh, I got item instead of items. Okay, I guess I didn't hit tab. Okay. Error name. Oh, how am I messing this up? Oh, we got some kind of error. The following test command failed with exit code 3. Hold on. Just the, oops. What's so wrong with this? Index out of bounds. Oh. Oops. Wait, what? Is this so init capacity doesn't actually initialize the values, I guess. Okay. Not sure with capacity to hold at least number of elements. Resulting capacity is likely to be equal to num. Do you know actually? Oh, okay. So length is set to 0 here. Got it. Okay. What other things can we do though? So I can't do that here. I have to do. Let's just copy this. Got it. Okay. Don't want to clone. Well, I want to test. So the capacity test right here. And then we have to do append or something. Or can I initialize all the things to a default value? Is there a way to do that? Deinitialize with dinit and okay. Init capacity, insert slice. What does that do? Insert slice items and index I by moving list to make room. Okay, I'm still not entirely sure how to initialize things. So we have an append command, so that works. You know, we can maybe like list.append 5, oh, not 510, and we can test to see if item 0 is correct, right? I'll have to try this. This potentially can throw an error, I guess. That works. And then if I change now, I can do like list.items 0 is equal to 25 or something, and then I can see if this passes. Right? Okay, so we understand that stuff. Kind of an idea of how this array listing works. How are we doing on time here? Okay, we got a good 15 minutes. Okay. Kind of got a little distracted by this dynamic array stuff, but at least we understand it now. I'm going to just put this code out of here inside my Zig notes. I'm going to get back to, I'll probably rewrite this stuff in a way that I understand better. Hold on. Yeah. Okay. I'm just going to put this notes here for here. I'm going to come back to this at some point. Ooh. Okay. So we would have to, what we would do, it wouldn't be like this, so it would be more. How would you actually make this a property? You know, what is the actual type? Because you kind of do that, and what ends up being the property? Because I know I can't. How do I end up doing this as a struct? Has to be something like this: sub items array list item. Oh, so you have to do like standard array list hitbox. Does that work? Okay, well, I'm gonna go back and copy the tests back over because I want to use this to test hitboxes real quick. I don't need this one. So we're gonna do what we're gonna do is we're gonna make a var group equals this hitbox group, and hold on. Oh, we're just gonna default this to like 0 and 1. Okay. And okay. Hopefully that works. What do we want to do? We want to do something like hitboxes. Does it take self? Oh, there's like something here. Do I do resize? Just the length to a new length. Does not initialize added items, if any. So can I just do like append hitbox like 0, 0, 200, 400, something like that? Does that work? Or does that work at Zig at all, to be honest? So we can do testing. What was it? Hold on, not list, but it would be something like group.hitboxes dot go back up to the original test here. You can learn a lot just looking at the tests, by the way, because it seems like everything in Zig has properly tested. So that's one really nice use of it, having a built-in testing framework in the language. Oh, it's items.length. Okay, so it's like a slice like other things. So items.length. So it should equal 1. Does that pass the test? No, missing filled hitboxes. 34. So hitboxes does not have a default here. How would I initialize that? Like equals, let's just say hitbox init capacity. Ooh, really doesn't work. Oh, that's why it's not a hitbox.init capacity. Let's just say 1 for now. We can assume you're probably gonna have 1 hitbox at least. Okay, does that work? What'd I do? Don't need that. Note, standard memory allocator declared here. Oh, I need to provide an allocator, right? Oops. Let's just say it's the standard. Is there allocator? Does that work? Is that a standard allocator? I don't know. Hold on, let me test allocators real quick. I don't know, or check allocators, or the standard allocators I can use. Choosing an allocator. Let's just pick one. There's a heap allocator. Are you linking libc? In case you use C, allocator is likely the right choice. Are you making a library? In this case, except an allocator is perimeter in line. Okay. So the maximum number of bytes you will be bounded by a number bottom. So yeah, let's do standard heap. What do we got? What kind of allocators do we have? The test allocator, got the C allocator. You know what? Let's just go with the C allocator for now. What the problems? Dependency on libc must be explicitly specified in the build command. Well, that's all fun. That's dependency on libc must be explicitly specified. Really? Sorry. I don't know what's going on here. Dependency on libc must be explicitly specified in the build command. Okay. So this depends on malloc. Okay. Is there any other allocators that's not dependency on libc? Is there anything in the test page allocator? Heap.allocator. The arena allocator, what is that? Oh, okay, it seems like the arena allocator might be the way to go. Okay. So I need a link against libc, I guess. I didn't realize that had to be required for using the allocator. Hold on, give me a second. Oh wait. Expected type mem allocator found type. So that's wrong. Okay. Is this not? What is going on here? I'm gonna look at the right documentation first of all. Let me make sure I'm in the right one. Oh. Why can't I use the arena allocator? Oh, I have to like manually. Oh, okay. This is how I have to use it. I have to set things up like this. Well, boy ye. Okay, let's just make that a constant for now, and we're gonna get back to life here. Let's just say character arena allocator for now. Let's call it that, and then I don't know about the lifetime of this. I'm just gonna like wing it. You know, I don't know the lifetime of things like this, to be honest. I'm just wondering why this is an error, first of all. Expected type standard mem allocator. Found standard heap arena allocator. So what do they do here? Oh, you have to get the allocator from it. Oh. Okay, that makes sense now. Oh, it's a function. It might be best served. It was called get allocator. Okay, we got different errors now. Unable to evaluate constant expression return. Where is this coming from? Set 37. Okay, let's not do this then. Let's do oops. I'm gonna do something like this, right? It's not a init capacity, it's a init for now. Get the allocator. Array access of non-array type hitbox. You're right, you're completely, wait. Array access. Oh, I guess that's what this is. Oh, so I have to be explicit, right? Didn't realize that would be array access. Error is ignoring. So before we have to try to do this, this is actually an error, potential error. Got it. Okay, that passes. Yeah, I think we're gonna have to split this off into another part pretty soon. Unfortunately, we had to spend time learning about array lists and allocators and how to use those, which I wasn't expecting. This happens, you know, when you're developing. You get caught up in something new you need to learn, but it's completely fine. It's expected. But we'll continue next time. But yeah, I'm gonna try a few more things and then we can wrap up. I'm sorry we didn't get to the interesting part of actually doing collision. But yeah, we are also learning, the whole point of this stream is we're also learning Zig at the same time. So, yep. Alrighty. Let's try, I want to try to see if we can access our items. And let's say dot, well, it's not going to figure that out for us, but let's say dot width is equal to 200. So that should be right, correct? Yeah, it passed. And that means height should be 400. Okay. Sweet. But yeah, we just come up to an hour here. If anybody has any questions before I finish up, I will I can answer them. What time is it over here? Yeah, it's about 10 o'clock in the morning here. Yeah, again, next time I guess we'll actually get to implementing loading hitboxes and things like that. We won't actually do loading, actually. We'll just make some test hitboxes as part of the hitbox group and do some debug display, things like that. But it's good we got to this because we really need to consider how we're going to handle dynamic memory or allocation using Zig. Zig, you have to be very explicit with this stuff. It's not just going to give you a system. As far as I'm aware, it's not going to give you just like, oh, system call is happening in the background, allocating memory, which can be a huge performance problem. So it forces you to think about this. There's no shortcuts, unfortunately, or fortunately, however you look at it. Adding a little bit of friction is actually useful for learning and doing things better. So actually, I might read up on like which allocators are provided by default. Maybe I'll look at some like patterns of handling things to see if see what strategy I want to use the most. I'm thinking maybe I'll just have like these structures that require dynamic memory. I will probably they'll take an allocator on initialization, pass that in, and then we'll have like a standard allocator that's used for the gameplay code, right? Or maybe a specific allocator for game data stuff, because that's going to be pretty much fixed and frozen until it's not going to be happening per frame. So we don't really need an efficient allocator as far as performance goes on a frame-to-frame basis, because it's all going to be allocated at the onset of a match and then deallocated at the end of it. So I'll see which allocator there is the best. But yeah, again, we'll continue with hitboxes, collision, and stuff next time. And I'm going to save this as part 1. But yeah, again, thanks for coming by. Appreciate it for everybody who are here and participated. And hopefully we get a lot more done next time. Well, I hope you all have a good weekend. I'm going to be heading out here. See you soon. Goodbye.